Okay, so we are going to be taking an x-ray of a knee, and I'm going to show you how to correct for an under or overexposed picture using the 15% rule. Currently, I have a knee to be x-rayed on my table. I'm at 40 inches, I'm in detent, I'm using the table bucky, and I'm perfectly aligned, so that's great. And then I'm also going to use this step wedge in the picture so that we can see how changing KVP is going to change our subject contrast. So with the step wedge, you'll see that one end is really thin and one end is really thick. Without me telling you, but I'm going to tell you anyways, which end should be black and which end should be white on the x-ray. Think about it. If I have a really thick part right here, it's going to attenuate all that radiation as it's trying to go through, meaning it's going to protect the film underneath and it's going to be white. This part is very thin. It's going to allow the radiation to go through pretty quick, so this end should be black, okay? We have the technique set up here on our control panel. I already clicked on lower extremity and found our knee technique, and we're going to use 68 kVp and 8 mAs. Remember, kVp is the strength, mAs is the quantity, so it's like how strong the balls are being thrown and how many balls I'm throwing at the patient, right? Notice right here, this line right here is going to show my DAP. Currently, there is 0 milligray centimeter squared. The DAP is reset up here. So if I hit menu, I can actually go to a DAP screen, and then I can reset it and then go back to the screen that I was just on. Obviously, it's already at 0 now, so I don't have to reset it. This is a piece together system, so it doesn't automatically do this stuff for us. You may or may not have a DAP system at your facility. DAP is fantastic though, because DAP is made up of two things, okay? One is your dose. This is my dose, 68 at 8. So obviously if I increase my mAs, I'm going to probably increase my DAP. Increase my KVP, I'm going to increase my DAP, but also the size of the collimation, right? So if I have wide open collimation, I'm going to receive more radiation than if I have a tight collimation. So tight collimation area is going to affect the dose area product, as well as the technique is also going to affect that. So my control panel is all set. So now I'm just going to take my exposure, 68 at 8. I have a new patient, new exam set up. I'm going to take that picture. And now let's talk about it. Okay, so here's that technique that I just took. You'll see it's 68 kVp, 8 mAs, a DAP of 238 milligray centimeter squared. Remember, that's made up of this technique, but also the size of my collimation, which is shown here. And then my EI is 536, and then my DI is 0.30. The EI is the exposure index. It's how much radiation the receiver actually received. Our TI is actually listed up here at the top. Our target exposure index is 500. Our EI was 536. So we were looking for 500. We gave the machine 536. The DI is a mathematical equation that happens behind the scenes that tells us how far the EI is from that target index. So our DI is telling us that we are at 0.3, which is basically a 0. So we rocked it, really. So our EI is 536, which means I'm a little bit overexposed because I was aiming for 500, which is going to be a mathematical equation difference, deviation index of 0.3. Most of the time, we are looking for a -3 to a +3 DI, which is going to be known as our exposure latitude. Those are our passable images. And I'm going to show you what those look like really quick and what they do to the dose and also the how it affects the technique. Okay, so I'm just going to put all of the stuff on this board so we can kind of go over it together. So remember, the technique we did was 68 at 8. The target exposure index for our computer, our system, this is different across the board, so don't think that it's like everyone needs a target exposure index of 500. Ours is 500. I think of it as like how much radiation it's looking for. It's looking for like X amount of radiation. In this case, it's looking for like 500 units of radiation. It's definitely not that. It's a lot more than that, but that's how I kind of think of it because there was no units with this. The EI is 536 that we shot. So this 68 at 8 gave us an exposure index of 536, which is pretty freaking close, right? We were looking for 500, we gave it 536. There's a mathematical equation that, thank God, we don't need to know because we're just X-ray technologists and we don't need to know this, but we do need to know that DI stands for deviation index, and it's how far that EI is from the TI. In this case, the 536 is pretty close to 500, so that's how we get a DI of 0.3. I also have the DAP listed here. We had 238 milligray centimeter square. There is a unit here. And I'm going to show you now what happens when we change one of the variables and how much it makes a difference on the picture. So the first thing that I'm going to do is demonstrate what happens when we half our mass. So right now we're at 8 mass. I'm just going to bring it down to 4 mass. Great. I already reset my DAP. You'll see that it says 0 right here, and I'm going to take that picture. And now we're going to take that picture at half mass, 68 at 4. Let's see what happens. So check this out. So all I did was half my mass. I went from 8 mass down to 4 mass, and you'll see that my KVP was still the same. My dose literally is cut in half. This is the most important part. This is the most important part. When you half mass, you are halving your dose to the patient. Now, DAP is not actual dose to the patient. It's the dose area of products. It's how much radiation is going to that area, but it will equate basically to how much dose is going to the patient. The EI is now 252 and our DI is now negative 2.97. Basically a negative 3. Ooh, more to talk about with that. So we're back at the whiteboard. So I'm going to just show you what happened when we changed our technique. When we cut our mass in half, literally we went from 8 mass down to 4 mass, you'll see that a bunch of things changed. One, our EI went from almost 500 down to almost 250, right? So it literally got cut in half. The DI goes from basically a 0 to basically a negative 3, negative 2.97. So remember I told you the exposure latitude is going to be between negative 3 and positive 3? That means that that is our passable range. The radiologist decided that a negative 3 means that that is half underexposed, but it's still a good enough picture that they can make a diagnosis. Obviously, it would still go in the other direction too. If I wanted to shoot a +3, which means I am 2 times overexposed, I would have to double my mass, right? So if I half my mass, and this is the only thing I changed, everything else was the same. Notice what happens to the DAP, okay? So one, it does show us a DI of negative 3, which does mean that I am half underexposed. Notice the EI is now half of what it used to be. But the biggest thing is the dose has changed so much. The dose has gone from 238 milligray centimeter squared to 118 milligray centimeter squared. So, I mean, it's not 100%. I think 119 would actually be half, but it's basically half, right? So we have saved half of our... Okay, so now I want to show you how we would create a +3 image. Remember the 68 at 4 gave us the negative 3 DI image? If I bring it back to the technique that we started at, which was 68 at 8, that was our 0 technique. Remember? Make notes if you don't remember. Now, if I were to double this again, I go up to a mass of 16. I did reset my DAP, but what do you think is going to happen? Now, when I halved my mass, it brought it down to a negative 3. So if I double my mass from the original picture, it should go to a positive 3, right? Which means it is now 2 times overexposed. Well, I've doubled my mass. What do you think is going to happen to our patient dose, our DAP, right? Should also double from our original number. So if our original number was 238, it should go up to 470 something, right? 476-ish. I'm just guessing, rather kind of don't really do math that great in my head. 68 at 16. Look how cool this is. I literally doubled my mass, and that's the only thing I did. KVP was still at 68. Now my dose has literally doubled. It went up to 480 milligray centimeter squared. That's basically what I thought it was going to go to. Our EI went to 1027 and our DI is now positive 3.13. Let's go to the board. Okay, so we're going to put our +3 numbers up on the board now. So our EI shot at 1027. Again, we were looking for an EI of 500. That's our target exposure is 500. We shot 1,000 basically, right? Which means that I am 2 times overexposed. The computer was looking for 500, but I gave it 1,000. Just a little bit over 1,000. The reason why I did that was literally all I did was double mass. I went from 8 mass to 16 mass, which means now I'm using 2 times more mass, 2 times more balls. Instead of throwing 8 balls at the person, I'm throwing 16 balls at the person, which means that I have given the computer 2 times more technique than it needed, giving us a DI of +3, plus 3.13 was our actual number. So the DI, a +3 is telling me that I am 2 times overexposed. It is still within my exposure latitude, right? I am allowed to send images that are between -3 and +3. If I send images that are 0, it's perfect. Mwah, we love it. We want zeros because that means that we gave the computer exactly what it was looking for. If I shoot a +3, I am 2 times overexposed. The radiologist can still work with that and they can still make a diagnosis, but you'll notice the DAP, and this is where I'm really trying to drill this in. The dose has gone up from 238 to 480. So it's basically doubled. Doubling mass has doubled my dose, or my DAP, which is equivalent to dose, right? So I am saying that by just doubling mass, by going from 8 balls that I'm chucking at the person to 16 balls that I'm chucking at the person, I've literally doubled my dose and I've given the computer 2 times more technique than it needs, right? Why this all matters, right? So there's another way to change for a 0 to a +3 to a -3, all of that. And that's with the 15% rule, and that's changing KVP. I'm not going to get into that today because this already ended up being a lot longer than I thought because I go on tangents and that's just what I do. But if this is my passable range, right, this -3 to a +3, look at the difference of the dose, right? 238 is perfect. We gave the computer exactly what it was looking for. It gave us a dose, a DAP area, dose area product of 238. But if I were to half my mass, my DAP cuts in half, right? So if you're the patient, would you rather have 8 mass being thrown at you or 4 mass being thrown at you? Look at the difference in the dose in the DAP area product. Now I can get a dosimeter out and we can do that in a slightly different unit, but the DAP works fine for what we're doing. If I were to double my mass, which who on earth is doing an x-ray of a knee at 16 mass, okay? That's problem number 1. We've used way too much technique. I'm using 16 mass now. Look at what happened to my dose. It has doubled, okay? So if this is my passable range, is it really passable? Like, what if you take your first picture at 16 and you're like, oh, I shot a +3, I can send it, yay. But then you just keep taking all the rest of your images at +3, your oblique and your laterals and stuff like that. No, like you're giving that patient 2 times more dose than they needed on just the first picture. So real life scenario, what do I do, right? Because I also still work at the hospital. So if I was crazy and I thought she used 16 mass for a knee x-ray, which on a new digital system is way too much. On CR, maybe it's appropriate, but for our system at least, it's way too much technique. I would send this first image, right? Because it is a +3, which means I'm 2 times overexposed. I can send it. It is within my exposure latitude. The radiologist told me is passable. But you bet your bottom dollar that I am fixing it for the next couple of pictures for my oblique or oblique, however you say it, images. So I would half my mass because I know that it's literally going to half my dose. And it's going to give me that 0 picture that I'm looking for. Superstar.